Okay, hi girls. Hope you are having a nice Easter and yeah, I hope you've been resting and taking care of yourselves. Um, what I'm going to do, as I explained, is I'm going to upload, I've condensed it down to 3 videos, and it's from the Blue Book, and the topic is functions. Okay, so this video, and then I think another 2 just for functions. And again, you can do this over the 2 weeks if you've been working flat out, which I know some of you have from the messages, I've been getting. Take the break. But I will, but please be, if you're not going to look at this new material, you're going to wait till after Easter. Please, be doing some revision, because even though it's time to rest, and I hope you have been over the weekend, and now it's Monday, it is important to be on for this Easter holiday to be doing work as well. Okay, but obviously, number one thing is to stay well, stay healthy, and all that. Okay, so what I'm going to look at is, as I said, functions. This chapter, it starts on page 230 of your book. Okay, now functions we deal with all the time, especially in higher level maths. We're constantly dealing with them. We've just finished integration, we did calculus, we were dealing with functions there. We were dealing with let's say cubic functions, quadratic functions, linear functions, trigonometric functions, exponential functions. There's so many of them, right? Basically, in its simplest terms, a function has an input and an output, okay? I.e., like coordinates, x, y, okay? So let me just start by writing a little title here. And I'm just going to write what page so you know they're on. Okay, so functions, as I've just written there, page 230. Read through these pages just to familiarize yourself with this as well. But I'm just going to kind of try go through the key things. So what I've said there, a function has an input and an output. I'm just going to write that here. And the typical function we've been dealing with is to do with graphing, where we have a coordinate x, y. X normally is your input, y is your output, okay? Now, there are some examples that we would have dealt with that actually aren't functions, they're called relations. And I'm going to talk about in the video in a few minutes examples of that, because sometimes you will be asked, is the following a function? So sometimes you can have a situation where there'll be this, inputs, outputs, but they may not be a function. There's not that many, but there is a few examples, okay? But I'll talk about this in a few minutes, okay? So just to start, what I mentioned there, I'm just going to write up a few functions. So let's just say y equals x squared minus 4. You should be thinking to yourself, okay, that's a quadratic function, yeah? So here's your input. What they're asking you to do, the rule here is square the input, take 4 away, okay? And just picture what that would look like as a graph. It would be a U-shaped graph, okay? Another function, y could be equal to cos 2x. And I'm bringing that in because trig graphs and trig functions come up a lot for us, okay? So that would be where we've the input doubled, and then it's the cos of that function, okay? And just in terms of what that looks like as a graph, it's called a periodic graph, and it's like a wave, okay? And then we could also have a function that looks like this, and I'm going to just throw in f of x here, because f of x and y mean the same thing. It could be e to the power of 4x, an exponential function, okay? Just 3 examples of functions there, okay? Just so you can see, yeah, we're dealing with these all the time, okay? Now, basically just a few words, and again, you will have come across these before. The first is the word domain, and what the domain is, it's your inputs, your set of inputs. So your x values will be your domain. Where we would have seen this would be a lot of the time when we're given a function, we would be given this beside it, where x is less than or equal to 3, but greater than or equal to minus 2. It would say in the domain. So they're saying there, use the inputs between minus 2 and 3. Okay, so that's just an example there. Okay, so usually, again, inputs usually is your x value, but I mean, sometimes in some situations it could be t if you're dealing with kind of situations with time in it, okay? Right, Then there's another word. Now this this word can mean kind of two things, I suppose. Within stats, it means the biggest minus the smallest. But for this, our range are our outputs, our actual outputs. Okay. So when we go about subbing in our inputs, the outputs we get. So usually this is your y value. Okay. Okay. So you again would be familiar with graphing any of these by doing let's say a mapping, not a mapping diagram, a table of values. And I just want to bring in here a mapping diagram because it may be a while since you've seen that, okay? So a mapping diagram is another way of representing a function, not just its graph, okay? So I'm just going to draw one in here, okay? They're like two oval parts, okay? And I'm just going to have a look at this particular one here. So I'm going to put in my inputs, or this is my domain. Okay, and over here, I'm going to put my outputs. Okay, and these are going to be mapped on over here. So what I want you to think about while I'm doing this is, what do you think the rule is here? So see the way these are the rules. Square the function minus 4, double it and do the cos of it. Here it is, raise it to e to the power of 4 times it. Okay, so I want you to have a think about what this one is going to be. Sorry, a bit messy. Okay, so looking at them, is there a rule you can think of that's happening to get from here to here? And remember, this is your domain. And I hope you're thinking to yourself, look at those numbers, you're squaring each of them, okay? So the rule for this, we'd write it down as y equals x squared. Can be also written as fx equals x squared, and particularly in functions, they'll be using fx because sometimes you may have two functions and they'll call it fx and gx. Or another way they sometimes write them is this, with an arrow. Okay, so these three are all mean the same thing, just different notation, but all mean the same thing. Just making sure I spelled that right. Okay, so the couples here, so when you are doing functions, you've couples. So your couples here, if you write them down, would be minus 1, 1. You'd have 1, 1. You have 2, 4. And you have 3, 9. Okay, so they're your couples. Now, just interestingly, your domain is minus 1, 1, 2, and 3. Okay, so if I wrote that down here, your domain is minus 1, 1, 2, and 3. Okay, your range is 1, 4, and 9. Okay, this brings me on to another idea here, which is called the codomain. And I'm going to tell you what that is here. It's 1, 4, 9, apologies, 9 and 16. So your range are your actual outputs, okay? So I'm just going to write that over here for range. Actual outputs. Whereas your codomain are your possible outputs. Okay, so these are the ones that are actually being mapped to, but you can see here you've got a 16 that's left over and it hasn't been, okay? So that's the difference between range and codomain. Now, yeah, you could be asked if a relation is a function, okay? Now, I'm going to be out of space here with this. This is just a little introduction. I might do this. I might put up another video. Well, no, we'll let it be long. But if you just, anything you need to take down now, take down of that. So that's just a short introduction. And I'm going to just explain then how you would tell something's a function or not. And I'm going to do an example of a question, okay?